Okay, so today we're going to learn a little bit about the proportionality theorem and the mid-segment theorem. Now, triangle proportionality, we've been doing that with similar triangles with dilations. It's just a specific instance of that. It's the instance where you have two triangles, one on top of the other, and you have them with two parallel sides and one shared angle. So here's our shared angle, and here are our parallel sides. Whenever you have a situation like this, you have two similar triangles, and you have a proportional relationship between these and these, which is great because you notice that these two pieces are not actually sides of triangles, but they still have a proportional relationship with sides of triangles. So it's a little bit of extra information we get. In addition to having similar triangles, we also have similar pieces there. Little thing, if the line divides the two sides of a triangle proportionally, then then it is parallel to the third side. Cool. So the reverse of that statement is also true. Let's go ahead and scroll down a little bit and see where this would come into practice. Now, if I look at this problem, I'm actually not going to solve this using the triangle proportionality theorem. The reason for that is I don't know this piece, but I do know this whole side. I know that whole side's x, and what I actually want to find is x, so I'm just going to go ahead and use the big triangle. So I know x. Now x corresponds to 7.2 because that's my other vertical side. Now I want to use the hypotenuse. Well, I want to say hypotenuse, but I don't actually know that this is a right angle, so I'm just going to use the other side that quite possibly is the hypotenuse. I'll go ahead and make that green for clarity. So I know that I've got my two little sides, 7.2 and 8, but what about on the big triangle? This whole distance, well, that's 8 plus 4, which is 12. Okay, from here I could cross multiply, or I could just say, hey, x is just being divided by 12, so I'll multiply by 12. Over here, that'll cancel, and x will be equal to the product of 7.2 over 8 times 12. Which is 10.8. And then we're done. Okay, let's do another one. Oh, now this one, we actually know all the little sides. So we can use the triangle proportionality theorem. I know these two will correspond. So 60 over 180. And these two correspond. So I'll have 8x minus 20. I'll have 36. And then I will go ahead and cross multiply on this one. Now I know 60 times 36 is 2,160. But what about 180 times 8x minus 20? One common mistake some people are going to make, but not you because you watched this video, is they're going to think about this and they're probably just going to multiply 180 by like 20 or something. But if we wrote this out and said, hey, we have 180 times 8x minus 20, we need to distribute that. So we need to multiply both of them. So we'll have 180 times 8x, which is equal to 1,440x minus 20 times 180, which means minus 3,600. Okay, and now we can solve. Let's go ahead, just for sake of clarity, I'm going to put a little squiggle line there so you know that those two aren't connected. This was just background work over here in blue. Let's add 3,600. Yeah, 1,440x equals that sum, which is 5,760. Then we would divide 1,440. And 5,760 divided by 1,440 is 4. So x is 4. And we're just solving for the value of x. So we're done at that point. Okay, now again, I don't know this little side, and I'm just solving for x, so I'm just going to go ahead and compare the big triangle to the little triangle. So I'm going to have x as one side of my triangle, and the other side of my triangle is this whole thing, which is 7.7 plus 2.2. Oops, I don't know why I put extra decimal places there. I apologize. Let me fix that. I guess I needed that one. That'll give me 9.9. So 9.9. And that corresponds to, x corresponds to 4.9. And 9.9 corresponds to 7.7. So x times 7.7 is 7.7x. And 9.9 times 4.9 is 48.51. Let's divide each side by 7.7. That'll give me 6.3. All right, let's keep going. All right, this one, again, that's a proportion. Now we're trying to solve for AB. Okay, so we just need to find right here. So we need to solve for AB. So AB would be corresponding, actually AB would be corresponding to 18. And then 12 will correspond to 22. Now you might wonder, why did I decide to put AB on bottom? Well, sometimes I like to come up with shortcuts in order to solve these problems. And sometimes setting up proportions is hard. So what I like to do is I like to say, hey, there's actually a shortcut here. If this is the line AB, then the shortcut for setting up the proportion would just be to actually draw in the proportion on one of these guys. So we'll have 12 over AB, which we see right there, and 22 over 18. Let's go ahead and solve. We'll cross multiply here. 22 times AB is 22AB, and then we have 12 times 18, is 216. Let's divide by 22. And we have AB is equal to kind of a messy decimal, which is 9.818. Now we want to round this to the nearest tenth, which is the first digit after the decimal place. Will that 1 make the 8 round up or stay the same? It'll make it stay the same. So AB is equal to 9.8. Let's talk about the mid-segment theorem. Now, we know midpoint. Let's think about midpoint for a second. Midpoint on a line was that point in the middle of a line that cut the line into 2 equal pieces. Well, guess what? Mid-segment is the segment in the middle of a triangle that cuts the triangle not necessarily into 2 equal pieces, because certainly the area of this section marked in green now would be larger than the area of the section marked in orange. However, you will notice that the sides are divided into 2 equal pieces. So the triangle might not be, but the sides are, which is great. You might be wondering why that's useful. Let's find out. Another thing that I want to point out to you is this formula down here, where it's saying that BC, let's say BC was 8, then we would know that DE is half of that, so DE would be 4. Or let's say I told you that DE was 5, then you'd know BC was 10. So not only does it cut the other 2 sides in half, it is half of the side that it is parallel to. Let's work an example. All right, so we want to find this is A, B, and C are midpoints. Now, if they're midpoints, then that means that all of this triangle in the middle is made out of mid-segments. And we're trying to find the perimeter of ABC. Okay, so let's trace that out. A, B, C. Okay, so we're trying to find the perimeter of this inside red triangle. Now, I already know that perimeter is just all my sides added up. So I already know I have 22. So it's going to be 22 plus something plus another something is going to give me my answer. Now those other somethings, well, first one is going to come from over here, from AC. Now I don't know what AC is, but I know this is 38. And that's double whatever AC is. So if I want to find out what AC is, I'll take 38, I'll divide it by 2. And that will give me 15 plus 4, 19. And over here, I need to find this side length. And I don't know what it is, but I know this is 42. So I'm going to take that 42, I'm going to divide it by 2. That's going to give me 21. Which means I need to add 21 and 19. I add all these up, I'll get my perimeter. So that's 40, 62. And are we given units on any of these? It doesn't look like it, so I can just write units if I want, or I don't have to write units. And that'll give me the perimeter of the small triangle on the inside. Let's look at this one. Again, we are given that they're midpoints, which means I have mid-segments. And this time I want to find the perimeter of ABC. And in this case, ABC is the big triangle. Now, I already know one side is 24. I just need to add up the other two sides. I notice that this side is 8, so if I want to find the side AC, I would need to take that 8 and multiply it by 2 to give me 16. And I see this side is 11. So if I want to find AB, I'll take 11 times 2 and give myself 22. I'll add all of that up, and 62 is my answer again. That's an interesting coincidence. Your answer won't always be 62. Just so happened to be on these two examples. Notice when we're trying to find the perimeter of the little triangle inside, we are cutting the lengths of my outside sides in half. And when I'm trying to find the lengths of my outside triangle, I am doubling the lengths of my inside triangle. All right, here's our last example. We're given that they are mid-segments because we know that those are midpoints. And I'm trying to find A, B, C. And, oh, that's nice. I already know two of my sides. So I've got 22 plus 20 plus, we only need to find one side here. And it's this side, AC. Now I know over here is 42. So I'm going to take that 42. I'm going to divide it by 2. I'm going to get 21. And we'll add all of those up and we'll get 63. Okay, so we get a different answer. Anyways, that's how we use the triangle proportionality theorem and the mid-segment theorem in order to solve for perimeters.